All right, in lesson 6-8, we're going to be adding, subtracting, multiplying, and dividing complex numbers. So the one thing we need to know before we get that is the standard form of what a complex number is. The word complex means there's both a real part and an imaginary part to it. So if you look at this standard form, a plus bi, a would be a real number like 3, and then bi would be something like 2i. So there's a real part, just a plain real number, 3. And then the imaginary part is here, this 2i. So real numbers, or the real part would be, like I said, just the 3. And then the imaginary part, if it's just an imaginary number, would be 2i. Remember, real numbers can be both rational numbers and irrational numbers. So rational numbers can be written as a fraction, like 1/2, or they're repeating decimals, which can also be written as a fraction, like 1/3. Irrational numbers cannot. It would be something like the cube root of 5 or pi. So there's a real part, and then there's an imaginary part. A pure imaginary number, we would know, would have no real part and just an imaginary number. So something like 7i, or I root 2. A complex number is when we take those two things and put them together. So we have a real number, and then we have an imaginary number. And it could be a negative imaginary number as well. So what we're going to do now is add, subtract, multiply, and divide these things. So the process is fairly simple. When we add or subtract complex numbers, we just add the real part with the real part and the imaginary part with the imaginary part. And the same idea when we are going to multiply. So here's an example of subtraction. So we have 3 minus 4i, that's a complex number. And then we're subtracting the complex number -5 minus 2i. Now first of all, I'm going to distribute this negative through. So we're adding 5 and we're adding 2i. Now I can add the real part with the real part and get 8. And I can add the imaginary part with the imaginary part and get -2i. And in that order matters because we're going to be writing all of these answers in standard form. So you're going to have 8 minus 2i in standard form as your final answer. Let's do the same thing but sum these two complex numbers. Very similar idea, really not much else happening other than we need to put together the real part with the real part. So this time it would be -2 and imaginary with imaginary. So this is going to be -6i. Let's try multiplication. We're going to multiply 3i by the complex number 5 minus 6i, and then we are going to write the answer in standard form. So just like when I multiply a real number times a quantity, you distribute that quantity through both terms of the binomial. So it's the same idea with a complex number. So we really have 3i being multiplied to the 5, and then 3i being multiplied to the -6i. So now, when we multiply, it's the same idea. We multiply real part with real part, so we're going to get 15. And then we have I times no other I, it's just I. And then here we have -3 and 6, so the real part is -18. And now we have I times I, which is I squared. Now don't forget, you can't leave I squared because I squared by definition is -1. So we have is 15i minus 18 times a -1. 18 times, -18 times -1 is positive 18. We want to write our answer in standard form, which means the real part first, imaginary part second. All right, now let's multiply these two complex numbers together. You can think of this just like multiplying binomials together. So you're going to do distribution, or the acronym FOIL if that helps you. So if we multiply the first two terms together, 3 times 2, those are both real numbers. We just get 6. Outer terms, we're going to take 3 and multiply it to the imaginary number 4i. inside term, we're going to have 2 times the imaginary number negative 7i. And then finally, if we multiply the last two together, we're going to have negative 7i being multiplied to 4i. So we have 6 plus 3 times 4i is 12i. 2 times negative 7i is negative 14i. And then negative 7 times 4 is negative 28. And then I times I is I squared. Don't forget, you can't leave I squared. You need to rewrite that as negative 1. So we really have negative 28 times a positive negative 1, so we get positive 28. Now we just go ahead and add here, so real number with my real number, and then imaginary number with my imaginary number. So real with real, we'll have 28 and 6, so 34. And then 12i and negative 14i for minus 2i. And that's in standard form, so we're good to go. Here, we're going to multiply together these two complex numbers. Notice they are conjugates of each other. They're complex conjugates. One is a positive 4i and one is a negative 4i. So let's see what happens when we multiply these together. So we have 6 times 6 is 36. 6 times negative 4i is negative 24i. 6 and positive 4i is positive 24i. And then for the last two terms, we're going to get negative 16i squared. So notice that these inner terms are inverses of each other. So negative 24i and positive 24i will add to 0. So we're just left with 36 minus 16i squared. And because I squared is negative 1, we're really just left with 36 plus 16, or 52. So just like earlier in the chapter when we used conjugates to rationalize denominators, we can do the same thing to simplify the quotient of a complex number. So if we want to get that I out of the denominator in this bottom example, we're going to multiply the numerator and denominator by the complex conjugate. So 2 plus I over 2 plus I. So in the numerator, when we distribute, we'll get 30 plus 15i. And in the denominator, the whole point of complex conjugates is that their inner and outer terms will cancel, so we're just going to multiply together the first two terms and the last two terms. And we're going to make sure we don't forget that I squared is negative 1. So what we have is 4 minus negative 1, or 4 plus 1, so it's 30 plus 15i over 5. And then that's going to go ahead and reduce to 6 plus 3i when we divide each term by that 5. Okay, the last thing that we're going to do is work with simplifying higher powers of I. So we learned that by definition, I is the square root of negative 1, which squaring both sides means I squared is negative 1, and that's a fact that we've used a lot. So let's look at some higher powers of that. If we think about I to the third power as this first example here, I can think of that as just I squared times I, because that would be I to the third power. We know I squared is negative 1 times I, so I to the third is just negative I. I to the fourth we could think of as I squared times I squared. We know each of these is negative 1, so negative 1 times negative 1 is just 1. So this is a good one to have memorized as well. So I squared is a good one to have memorized, and I to the fourth as well, because negative 1 and 1 are easy numbers to work with, and that's what's going to help us work with these even higher powers of I. So I'm going to look in these higher powers of I to try to break the i's down into I to the fourth times something, because then 1 times something, that'll be nice and easy. So for example here, for I to the fifth, I'm going to think of that as I to the fourth times one more I. So I to the fourth is just 1 times I, so we're just left with I. So let's try to the 6th. So same idea. I'm going to try to use I to the 4th. And then there would be 2 more to give you I to the 6th. So we know I to the 4th is 1. And we know I squared is negative 1. So 1 times negative 1 is just negative 1. And then same idea here. So we're going to use I to the 4th. And then I squared. And then 1 more I. So we basically, this would make sense. If we had that I to the 6th is negative 1, if we multiply by I one more time, we're going to get negative I. So finally, one more here, kind of going in order. So we have I to the 4 and I to the 4. So 1 times 1 would just be 1. And that also makes sense if you think about taking I to the 7th, which is negative I, and multiplying it by I one more time. You get negative I squared, which is just 1. Okay, what happens when you have really big exponents here, right? You don't want to sit there and have to go through breaking it down into all these little tiny i's. So what you want to do is, like I said, is look for that easy one to work with, I to the 4th. So go ahead and think about 2012. Divide that by 4. If you divide that by 4, you're going to get 503. So basically, I to the 2012 is I to the 4 raised to the 503. Remember, when you raise a power to a power, you multiply exponents. So really, this problem is just 1 raised to the 503, but that's just 1. So working with that I to the 4 really helps. What about if we do our zip code here, 90049? Let's try to divide that by 4. So if I do that, I'm going to kind of not quite show all the work here, but you're going to get 512. But there's going to be a remainder of 1. What that remainder of 1 tells you is how many i's are going to be left over. So what you have is I to the 4th raised to the, like I said, 22,512 with a 1 left over, meaning you multiply by I one more time. So again, 1 to any power is just 1. And then we have 1 times I. So I to 90049 is just I. Alrighty, go ahead and check Schoology for your homework on this one.